Dear participants, thank you very much for coming and joining us at this session. We'll be talking about very important things today, such as transportation and the technologies that exist today, the ones that are going to be used in the future. We're going to be talking about the transportation systems that will exist in a few years. Our speakers today are distinguished experts in their fields, leading managers of transportation companies, the people that drive the ideology of transportation development in Russia. And I would like to present to you Valentin Gapanovich, member of the board of the joint stock company Russian Railways, RZD, Mikhail Gordin, the general director of SIAM, Maxim Nagaitsev, the advisor to the general director for innovation at NAMI, Dmitry Nishenko, professor at the piston engine department at the Bauman University. I would also like to present to you two of my colleagues, my assistants. Since we're going to be talking about transportation today, I would like to ask the audience to write down your ideas about the transportation systems of the future, and then at the end of this session, we're going to read out your ideas, suggestions about the future, and the speakers will select the best solutions, and then at 12:30, when we have the presentation of the Crimea roster, we're going to be also distributing the gifts and awards to the winners. And now, let's talk first and foremost about such things as vehicles, transportation. Many of us know that there are very strict environmental requirements and standards that exist, which certainly limits the capacity of our industry. And people who live in large cities, they want to be able to move quickly from point A to point B. This is impossible with something that is weak in capacity. And of course, the power of the engines and the power plants are growing. And of course, our speakers, distinguished speakers, are going to be talking about those technologies that allow us to enhance and increase the speed of moving through space and time. And we're also going to be talking about the alternative sources of energy, the ones that are not going to be polluting the environment, but would still be quite powerful. And then I would like to give the floor to Mr. Gapanovich, and he will talk to us about how the railways are going to evolve. He is the person who has been driving the development of Russian railways. He is in support of innovation. And you all remember what the railways were 10 years ago. Now you know what they look like today. You've seen a lot of evolution. So, Valentin, the floor is yours. Thank you. We'll talk to you about the railroads, who will be celebrating 180 years anniversary this year. We will be celebrating this together. A few words about the Russian railways. 740,000 people working for this organization. 325,000, about 50% of them are young people under 35 years of age. And this is the structure of the railways staff. I'm not going to be going into the details of our achievements, but let me explain to you what Russian Railways is. It's 85,000 kilometers long. It's probably the longest stretch between Moscow and Vladivostok, which is 9,298 kilometers. We have to operate at temperatures between plus 40 near Sochi and to minus 54 near Labytnangi. In various climatic conditions, therefore, the requirements for the equipment, for the railroads themselves are very strict, and there are several time zones. The time difference is up to 7 hours. We have 5,337 stations in our network, and they are controlled from such control rooms, as you see at this picture. And if we take the example of West Siberian railroads, and my colleagues from that part of our railroads are here. This stretch is 1,777, and 108 trains are on that network at the same time. This is the so-called Moscow Central Loop or Belt, We just recently exceeded a record. In one day, we transported more than 400,000 passengers. And so far, we have transported 110 million passengers. We have dozens of trains. And together with the city Moscow government, the headway is about 4 minutes. And we hope that very soon there will be self-driving trains on the Moscow Loop. And today we are trying to introduce M2M technologies and all of the other advanced technologies. We want to digitize our railways, and everything is going to be tested on the Moscow Central Loop. There are very interesting technologies that are being introduced. It's great that some companies are working with us, and they are experts in the fiber optic communication lines. They are not just transmitting data, but they're also using those lines to control the roads. In 10 to 15 years, the railroads are going to be managed using these digital-based technologies. We're not there yet, but we are approaching that, and we are at the helm of it. We're working on this together with other U.S. and the European colleagues. We're also employing satellite technologies. It is impossible to operate our network without navigation systems. We have over 16.5 thousand of them employed. We use GPS systems, and one of the main technologies that we employ in our operations satellite technologies for all types of rolling stock. We will certainly talk about the environment. According to the World Energy Agency, the emissions of carbon dioxide of railroads is about just 4%. And we'll also be talking about the alternative energies. And if you compare our emissions to the U.S. railroads, European and the Chinese are the lowest. It's 11.7 of CO2 in equivalent of tons of CO2 per kilometer, net kilometers. Now, this is the locomotive, the gas piston engine using the natural gas as the fuel. It's been in operation for 2 years on the Sverdlovsk network for 2 years. They're using liquefied natural gas as the propellant. This is another one of our leading projects where we used gas turbine engines, and we believe that the future belongs to these types of engines for such locomotives. And the gas turbine is used here as a propulsion plant. When we supply the liquefied gas, it goes into the turbine, and then the turbine is connected to the generator. We produce electric power. We have about 40 patents for this technology, international patents. And all of this is being used very actively for 2 years. It's been operating at Sverdlovsk network, and the results have been quite good in terms of the reduction of the life cycle cost. And here we are going to show you some of the life cycle cost savings. It's 19.5% drop in the life cycle cost. And as for the environmental standards, I think we have exceeded by far the European environmental standards. So we're pretty clean. So together with our machine building industry, we are putting in new rolling stock and locomotive, including the electric locomotive 2ES10, EMU EP2D, and this is all done by our machine building plants. They are integrating robotics. And on this slide to the left, you can see how the aluminum panels are being welded in Yekaterinburg for the Lastочка trains. On the right, there is a conveyor which is completely robotized, where we are building freight cars. And that says to you that we use the robots quite widely at our machine building plants. This is another one of our projects. You probably heard about the port of Ust-Luga on the Baltic Sea. This year, their turnover is going to be 100 million tons. And this is the project under which we were using self-driving locomotives. There is no need for an engineer. And so we're using this pilotless method of operation. Unfortunately, we still have to have a person there for the simple reason because there is no legislation that supports such self-driving operators. But it's been quite successfully working for 2 years using this self-driving mode. We've tried these technologies, and the experience we've gained has been quite successful. This is the Luzhskaya station. We built it, and we have been operating it for the last 3 years. It allows us to move the cargoes, the freights from the ports of Russia, including the cargoes coming from the Ust-Luga port. The technologies that we use at the Luzhskaya marshalling yard, this allowed us to increase our productivity by more than 20%, and we plan on enhancing those achievements, and this is something that we're going to be propagated to the entire network of the Russian railroads, using those technologies that we've pioneered there. I should say a few words about high-speed trains. We started implementing this program in 2009 together with the German company Siemens. We set up high-speed transportation lines between Moscow and St. Petersburg using Sapsan trains. In 2010, we implemented another project which joined St. Petersburg and Helsinki using the speed of 200 kilometers per hour. We also linked ourselves to Nizhny Novgorod in 2010, and now, as you probably heard, we are in the process of implementing a project to establish high-speed communication between Moscow and Kazan. We also have a project we implement with the Chinese colleagues. It's called Eurasia Project. Essentially, we're talking about a link between Moscow and Berlin. It should take 72 hours in transit between Beijing and Berlin. We have the drawings for the rolling stocks. We've done the conceptual design and are in the process of developing the technical detailed drawings for that. As you probably know, at the Eastern Economic Forum, President Putin expressed the idea that we're planning to build a bridge to Sakhalin Island that would connect the island to Hokkaido. We're talking about the distance that will connect Paris to Hokkaido, and it's about 14,000 kilometers. It sounds like science fiction, but we've started developing designs for connecting the continent to Sakhalin, and there the gauge is 1 meter there at Sakhalin. We will change it to the wider gauge, and in general, once that is done, we'll connect this to the entire network of the Russian railways. Our experience shows that our bridge builders are capable of tackling the most challenging tasks, and this is the installation of the Crimean Bridge. This was done about a week ago. This is something that would allow us to say that there will be a motor link between the main lane and the Crimean Peninsula, and we are talking about the completion of in 2019. Together with the Russian industry, we work very actively towards creating the digital railways. We are trying to implement everything we can out of the digital world. I shouldn't probably dwell on this slide for too long. We'll just go through a number of streams in terms of digital services for freight operations. Of course, we're going to be using the blockchain technologies, and with some of the companies that are based out in Skolko, we are trying and testing these technologies. This is something that will allow us to increase the effectiveness of the transportation in terms of passenger transportation. Many of you have already used the digital ticketing systems, and for Sapsan, 36% of tickets are bought using electronic technologies. There are some other technologies that you've probably encountered when you visited our train stations. In terms of the infrastructural development, we use state-of-the-art equipment. We use digital rail track models. We use digitization and digitalization, and we use mechanisms and technologies in all of our machines that allow us to effectively manage and maintain our infrastructure. We work on developing our system through 2025 that would include heavy freight traffic. We are monitoring what is happening elsewhere in the world. We work together with Elon Musk, who in California is implementing his own projects, and they have achieved the speed of 300 kilometers in the Hyperloop. And I think this is the thing of the near future. Our colleagues in China have reached the speed of 600 kilometers, and so we have built this model, which sounds a little bit complicated, but this model shows us what has already been done, what needs to be done, and where we need to aspire to get. And this is an interactive model that allows us to look out into the future. Thank you very much.
Thank you very much for this very interesting presentation. We have learned a lot of interesting things. My question is as follows. Unpiloted or unmanned railroad transport. How soon are we going to see that en masse and on our railways? And are we talking about cargo train or passenger trains as well? 54 lines are already unmanned, and in Paris, all over the world, but in Paris and Tokyo and some other places, so they have resolved these issues already. We are actually leading in the European market as far as maneuver locomotives are concerned. You know, the shunting locomotives. And according to our estimates, we will expand our operations in this area in 2022. We do not have any technical obstacles here. Rather, the obstacles are of legislative nature, and as I already mentioned. Because, decisions have to be taken within milliseconds, and it is very important to have a regulatory basis. However, the technology already allows us to make this move forward, but we believe that by 2021, 2022, we will be able to resolve these issues together with the government. So it looks like within 5 years from now, in fact, I wouldn't say that this will be done en masse, but, on certain tracks, like between railroad stations and airports, this issue will be resolved. What kind of power plants will be used in such locomotives? What's your take and what's your stake? My personal opinion, my favorite is gas turbine engines and the fuel. If it were for me to decide, I would definitely transfer all the locomotives to use these engines and to use this fuel. But I think in 10 to 15 years from now, they will start to implement nuclear synthesis-based engines. So, I would like to give the floor to Mikhail Valerievich now, and now we will speak about aviation and what kind of technologies are used nowadays in aviation. Good morning. I will try to speak about aviation. Mainly, I'm the general director of aviation engine building institute, and it's part of it's actually part of a huge scientific center, scientific institute that unites a number of research institutions which are in the area of developing the new technologies. We'll definitely work with the industry, and we are providing assistance to industry. But the main thing is to develop new technologies that will be used in the future by designers to create new airplanes and new technologies. If we talk about aviation, civil aviation, this can be divided into three groups: regional, local, and long range. And the requirements, there are certain requirements applied to these three categories. I think it is very important for us to concentrate, to focus on local and regional ranges. And it is very important for a country like Russia, because we are a large country. It is also important for BRICS countries. It is very important to ensure accessibility to the airport infrastructure, and the transport should be affordable as well. We also have to comply with the environmental requirements. Therefore, the less fuel we spend, it is much better for the economy and for the environment as well, because the emissions go down. The goals that the world has and Russia has is to improve efficiency, fuel efficiency, by 30, 40, or even 50% by 2035. The technologies of the gas turbine engines, as of today, we have these traditional engines, and in contrast to the railroads, they are very close to their top efficiency, to their design efficiency, and a lot has been done over many decades in order to improve their efficiency. Therefore, there's very little reserve in improving their efficiency. Of course, aerodynamics may be improved, but we do not think that there may be a breakthrough improvement of efficiency in those engines. We are looking, of course, at electricity and electric energy. For instance, when we use a gas turbine engine in order to generate electricity, which is used then by electric motors to ensure movement, that would be topical for our regional planes, regional range planes. But we have to resolve a whole number of scientific issues. First, it's batteries, and maybe batteries or fuel elements. In any case, these are the elements of an aerial vehicle that would be preserving, keeping energy to sustain the flight. And then the number of kilowatts per kilogram, and gas turbine engines are very effective and very efficient engines. It is very hard to keep in line with them. Then the electronics that can actually control the flows and transmit them to the energy usage system, using photo elements, for instance, but I'm not quite sure that they will be too efficient here. We are now proactively trying to design in our country, and maybe we are leading to in certain areas using the superconductivity, which will improve the management on board. You can see the line here. The line shows how we see the development of aviation, and the numbers shown are the power consumption. For instance, original plane requires 1 to 2 megawatt A middle range requires 2 to 5 megawatts, and you see that 5 to 10 megawatts is required for a long-range airplane. So it looks like a very hard technical task, and we believe that regional plans will appear very soon. There are very many startups in the Western countries that are dealing with this, but there's a technological preparedness, for these regional range airplanes is very close. That's an obvious fact. The development of these electric systems is also very important, and we have very high requirements as far as failures are concerned, and these requirements are definitely much stricter than in other industries. Because any failure may be a critical failure in the aviation. In the course of design, there will be a lot of different knowledges acquired that will be transferred to other industries. A few words about unmanned aerial vehicles that will probably take their niche in regional and local on regional local routes. A lot of work is done in this area, and we were talking about the vertical takeoff cargo vehicles. And the main problem, in fact, here is the lack of regulatory and legislative base. It will be definitely very hard to create such a basis because the legislative basis that has been created for hundred of years, was based on the fact that on board we have a person, a human being, that cares very much about his or her life. And how to approach this, how to redesign the legislative basis, for the new requirements is not quite clear as yet. A couple more interesting things. Supersonic jets as a replacement to Concorde. There are a number of problems, noise problem, there's an active work going on in this area. There are a number of startups. There are definitely issues of engines, aerodynamics issues, and we believe that by 2030 or 2040, we will probably have business jets or small passenger jets that would be using supersonic power units. And the aerial vehicles with hypersonic speeds of the order of 6 to 7 Mach. But if we build such airplanes, these are very high-speed vehicles that would take small cargoes or a few passengers from Moscow to Vladivostok in about 45 minutes. But we're just starting to think about it, so we believe that these aerial vehicles may be produced within the period of time from 2050 to 2070, and probably you will be able to fly on board these vehicles, but I wish you a long life, so you can test these vehicles yourselves. So the aviation deals with these unmanned vehicles. However, there are legislative problems, and probably they will be firstly used for cargo transportation. Well, the fact is that I wouldn't blame the legislators themselves. It's not about a bureaucrat who doesn't allow us to do that. But unfortunately, we have a lack of knowledge in creating an adequate legislative basis. it depends, of course, on the experience that we have had for many decades. The aviation actually lives using the rules of 1950s. For instance, in order to certify a plane, you have to certify the generic structures of this plane. And then there may be hundreds of different so-called bulletins or specifications that that would refer to the rules of to the rules of using the plane. And it is much more complicated. So it's not about the bureaucracy or officials. Is it possible to use electric power plants for civil aviation and cargo aviation? We do have fully electric motors. For instance, the helicopters, toy helicopters, and they are being used very actively as of today. However, it is a different pair of shoes if you want to carry a number of passengers from one point to another. Have there been any? Well, it may so happen that the battery is too low, when the aerial vehicle is up in the sky, and then it has to fall because there is no energy. Well, the number of the best batteries that we have today, I would say 800 kilowatt, 800 per kilo. And if we take kerosene, for instance, it's 14,000 kilowatt. So 0.8 I'm talking about the best batteries. So just compare 800 and 14,000. There's a huge gap between these two types of energy. Let's talk about automotive industry. You are the person who actually created Kalina, Granta, a number of other cars. Good morning. I would like to throw in a provocative thought in here. Is there any future if we are talking about cars? Do cars have a future? Well, everybody here wants to have an electric car. No, I'm sure there will be people who would like to buy a Land Cruiser or a Panamera. A car used to be a very useful means of transportation, back more than 100 years ago. Only after the Second World War, we saw that a car was turning into a kind of a habitat, there appeared heating elements, radio sets, and so on and so forth. And today, living in the cities, when we spend a lot of time in driving our cars, we look at it as if our private space where we feel comfortable. But the cars are different, and they have different objectives to achieve. It's amazing to hear what Porsche says about its Gran Turismo with a huge trunk. They say, for instance, you have a family, you have 3 kids, and you start traveling with your family with an engine which is 500 horsepower engine. It doesn't look like a valid argument. It's probably just a demonstration of how prosperous you are. It looks logical if you buy a Land Cruiser, for instance, because it's a off-road vehicle, and this is a car that is this is an SUV that is very popular in our regions because it travels on any kind of road or off-road. But in towns, however, both Porsches and Land Cruisers stay in huge lines and in traffic jams. But 80% of these traffic jams consist of Kia Rio or smaller cars. But it doesn't matter, and the people have to keep these cars somewhere. They have to park these cars somewhere, and they park them around high-rise buildings, high-rise apartment blocks. But these people want to have these cars for very simple purposes, just to drive your kid to school and so on and so forth. Students in our towns have already mastered using car-sharing companies. In towns, it's becoming more and more popular.
And I just was surprised how really mushroomed those companies that offer the car-sharing services. They all bear different names. Belka, Strelka, there is an application that aggregates all of the car-sharing providers. Let's not touch that subject of information technologies for now. But what I'm trying to say is that a car, something that we have grown used to over the last hundred of years, something that was a desirable possession. This is something that is going to continue going through a transformation. We have outer regions where the distances between settlements, towns, is large, and therefore the car will be performing that function of just, moving you from point A to point B. And there are some vehicles that are very reliable. You don't really need to change anything in them, like a Land Cruiser or a Porsche. I don't think that the Porsche will stop being a sports car and would drive with less fun. Well, they introduced a Cayenne a few years ago, which was a new thing. They had always been a sports car. It had never had, the company had never had a Jeep or an SUV. And then the marketologists look at the map of the world, and they looked at the locations where they were selling their Porsches. And so the members of the board said, well, there are some white spots on the map. Why are we not selling our car there? And the answer was, well, we don't have roads there. And, well, that's why they changed their concept and started introducing an all-road vehicle. Some vehicles will stay the same. Some will continue performing the function of, essentially embodying your status, your income. And there are some people that are fond of horse riding. So even the horses are still there in our lives. But in the practical sense, in the cities where we do not want to carry those expenses and the extra chores, what awaits us is complete self-driving approach. And of course, there are speed limits in cities. Why would we need a vehicle that, of course, is capable of driving at 300 kilometers per hour, but you would still have to drive under 80 kilometers per hour. And if you go above this, then you will have to pay fines. And therefore, the requirements for the car are going to change. The cars are going to change as a result. If you look at the Namiz self-driving car or the Kamaz vehicle, this joint project has been around for 2 or 3 years. We started with the things like intermodal transportations between airports, terminals, train stations. And so the initial idea was to make a vehicle 10 or 15-seater. But the layout would be very symmetrical, would be very simple, and we decided there would have to be a family of those. Some of them would be a 4-seater, some would be a 20-seater. And that is changing, how the vehicles are going to be changed. And so when you call the cab, it's not something that is outside at your location. It's not sitting in your district, but it will be sitting at a parking lot and will come to you when you need it. And it's something that you can select, whether it's a budget or a comfort or a business class vehicle. And maybe some people will just be subscribing to a subscription. Speaking about self-driving cars, I think they're using the term of unmanned vehicles. I think we're going to forget about unmanned, without a pilot, pilotless. Well, there used to be a pilot, and we've just removed it. That's what it says to us. But we will try to do anything to make sure that we would still have this sense of that pilot still being there. The pilot, the virtual pilot, will use radars and other means to know where it is. But look at the airport. I mean, in addition to the pilot, you also have a traffic controller. The traffic controller provides the pilots with the required information about the environment, how to land, how to take off. And speaking about self-driving vehicles in cities, do we really need the car to be able to monitor the situation just on itself from inside the car? Of course, this is something that will be necessary, but we can also do some remote controlling. We will definitely know that there is a truck coming from around the corner this very moment. So on a daily basis, we hear reports about traffic collisions. Trucks have collided, or a car wrecked into another car, or somebody would come into the oncoming traffic. And we could sort of deal with this by installing GLONASS systems onto every car. Of course, a person can fall asleep at the wheel, but essentially we can control this car remotely and slow it down. And the vehicle, the self-driving vehicle, will just stop. But because the command that had been given to that individual, to that virtual pilot by the human being that had fallen asleep, was just not feasible. So, and to continue this thought, if with the GLONASS we would know how many trucks are coming on and what kind of other vehicles are around, we would know everything. And as they get closer to each other, we could alert people to be more attentive to what's going on. I agree with the people who spoke before us that we are looking at a very exciting future, especially because of the informatization. And with the cars, I'm sure we will see how the actual product is going to change by itself. Of course, we'll be talking about the new materials, about the new energy or power plants, but everything that we see everywhere else is going to be as relevant for cars as anywhere else. But as for the new materials, I think since our classical layout of a car is going to change, we will not have the engine that will be located at the front, or the traditional deformation zones when car collides, and therefore there would be a need to change how those restraint systems and airbags are changed. And is this always the case when a person is going to the oncoming traffic? Is it just going there headlong without trying to do something? And the likely outcome of this would be that the person is a sane person is trying to avoid a collision, and therefore we very rarely have those types of collisions that we model and test during the crash testing. Very often is just a scratch as two vehicles are meeting each other with their headlights, and not the full impact is seen. So the changes in the design are going to entail changes in the materials and these approaches. We want to be protected from all sides. And the very last final thing I wanted to say is that the city automobiles, city cars, are going to become parts of modular system, because these cabs could be installed on rail platforms without essentially leaving them, and use the advantages of the rail systems and cross a long distance at a great speed and leave your essentially bogie for another vehicle that would be then placed on top of this bogie and be used in that city. And you can be transported at long distance. Most likely, we're going to see how these systems get integrated into something common, including with those things that we'll see in the morning with a cup of coffee in front of us. Thank you very much. Maxim, let me ask you this question nevertheless. What are going to be the engines? Are we going to be looking at electric cars or hybrids? Of course. What will be propelling these vehicles are most likely be electric drives, because this is probably the most feasible thing today. We've seen how the piston-based engines are evolving, and they're very different now than what they used to be last century, and they will stay, but at lower speeds. Electric drive cars are going to be dominating in the future. As for long range, but will we have special roads for that? Yes, we will have to build such stations or thermal plants will also be required, or maybe hybrid power plants will be needed for the vehicles. So there will be a modification of the different pieces. And Dimitri, as the representative of the traditional engines, what can you share with us? Hello, first of all. I would like to join my colleagues in what they said. What awaits us is a very exciting period of time. We will be witnessing our transportation systems evolving. And if you look at the next slide I'm about to present to you, you will see this picture. It is something that shows us a brand of a well-known car maker. And I just wanted to show you how things have been evolving in the various means of transportation. There are 4 areas that are depicted here, and so the main thrust of this development route is that the way the vehicles look is defined by the power plant. You can see what has happened to the ground transportation, water transportation, air transportation. The speeds have changed. The effectiveness of such means of transportation has changed. And I wanted to use an example of the ground transportation vehicles, such as cars. We are using gas turbine engines elsewhere, but with the cars, we're using the traditional internal combustion engines that are based on the piston technology. And now the engineers are thinking how to use hybrid power plants and the purely electric vehicles. And they all have advantages and disadvantages. And the disadvantage of the electric cars is that, and that's what our colleague from SIAM said, the power capacity of the existing batteries is about half of the capacity of accessible hydrocarbon-based fuels. As for hybrids, we all know a great SUV called Volkswagen Touareg. Volkswagen have been working on that hybrid, and after 7 years of work, they had to recognize and admit that despite their efforts, the mixed fuel consumption of a Touareg is worse than that of a regular Touareg with the turbine engine. I'm certainly not against the trends, and we're saying that the electric car is going to displace the traditional cars fully. But I would like to say, and go back to the events of 120 years ago, the very first patent for an electric car was received by the well-known Ferdinand Porsche, and at the exhibition in Paris in 900, he presented his first electric car. And if we looked at the headlines of the newspapers in Europe at the time, they all were saying that in 20 years from now, all of the petrol-run vehicles will be displaced by electric cars. But over these 120 years, very little has changed. However, the electric car is evolving, and hopefully very soon we're going to be able to see capacitors that will have the required energy capacity. Now, speaking about the effectiveness of the power plants, I would like to show you this picture that shows you the real effectiveness. We are used to saying this: okay, we have 1 liter of diesel fuel. It is worth 40 rubles. 1 kilowatt of electric power, depending on the region, is anywhere between 2.5 to 6 rubles. However, we are forgetting the so-called other side, the flip side. But let's look at how much does it cost to produce 1 kilowatt of energy versus 1 liter of hydrocarbon-based fuel. Today, up to 95% of the price of the gasoline and diesel fuel are taxes and excise duties. And if we try to evaluate the cost of 1 kilowatt of energy, then we would see the financial and economic effectiveness of an electric vehicle is something that is going to suffer. And the vehicle with the classic internal combustion engine is going to be more effective. And if we all say no to hydrocarbon fuel, we will certainly see that excise duties are going to be introduced on electric cars. And so we need to understand how we're going to be calculating the real effectiveness and which common denominator we're going to be using. And we all know that every project is assessed in the terms of its effectiveness, financial effectiveness. And when you try to go to the international markets, you will be hard-pressed to understand which currency you would use, whether it's going to be a dollar, yuan, or something else, maybe ruble. So it seems reasonable to me to use the energy as the metric for measuring such effectiveness. And that approach is well known. It was something that was posited by German engineers in the 30s of last century. They called it exergetic analysis, and you can probably find this term on the internet. The next picture is demonstrating to you what are the barriers to using electric power for powering electric vehicles. Whenever we talk about environment, there is this understanding that electric vehicles are green, environmentally friendly, clean, and so it's a vehicle with zero emissions. But as we look at this picture, we see two borderlines, 2000 and 2030. The existing situation in 2000 and 2030 is the forecast. In red is the structure of thermal electric power plants. So if we have to power the battery of our electric car, then the cost of 1 kilowatt, the kilowatt of energy was produced at the thermal power plant. And so when we talk about the effectiveness and the friendliness of our vehicle to the environment, the question that arises, where is it better and environmentally friendlier to burn the hydrocarbons? Inside the vehicle or at the power plant? And the structure of power generation in the near future is not going to change. We will still have that share of thermal power plants about 15% higher. And these plans have shown that those forecasts are not going to be achieved because we see that the demand for electric power is increasingly higher than what is being produced. Another interesting picture, it shows you those problems that occur when you operate an electric car. The negative thing here is that when you use a battery, they serve 2.5 to 3 times shorter, for a shorter period of time than the regular engine. So you will have to resign to the fact that your range is going to be lower. And any gadget we use, a Nokia telephone that we used 10 years ago, they would hold the juice for a week. However, our contemporary phones will only hold it for a day maybe, but after half a year, we have to be always wired to the socket, so to speak, and that's because the longevity of our batteries is reduced by 2.5 times over this period of time. So this is a very serious problem and deterrent, so to speak. Speaking about those thermal machines, this is not a very bright graph, but let us see what has happened over the last 60 years. We're talking about the 1 liter power. That's how much kilowatts we can get from 1 liter of the engine's displacement. It used to be 10 kilowatts in the 1940s. By 2010, that number grew by a factor of 4. And of course, for the petrol-based ones, we are now about 100 kilowatts per 1 liter of engine displacements. Of course, there are problems there, but they are not insurmountable. Now, let's talk about the overall use of electric transport and the problems that are associated with this. Summing things up, I would like to say that so far, as of now, there are some problems that haven't been dealt with. I'm talking about the private transportation means primarily. And it is not quite clear where you can really go with an electric car if we don't have the infrastructure in place. And I've already mentioned the capacity of today's batteries. That's something that also needs to be addressed. And the most important barrier to mass-scale introduction of electric cars is that the electric vehicle engines are very inferior to the traditional internal combustion engines. And the capacity of the thermal power plants is certainly below what is going to be needed for electric power plants to charge them. Speaking about the future of the development of the power plants for transportation systems, I would like to highlight here some of the conclusions. It is clear to me that the way the power plants are going to be evolving, it is something that needs to be looked at together with the development of the energy power plants for the transportation systems. It is obvious that when we try to estimate the effectiveness of the power plant, you need to use this synergetic analysis in order to understand the true effectiveness. And then in order to find a global solution to the problem, I would like to suggest that we use the concept of developing the so-called universal or a versatile fuel. I think electric motion and electricity is very interesting, but we all need to realize that those processes that are taking place inside thermal machines, and you can see most of these power plants are thermal-based, and 90% of all vehicles are now also thermal-based. So those processes that are taking inside thermal machines, the oxidization of hydrogen, these are the processes and of carbon. These processes are happening inside our bodies, inside of animals and plants. And if you properly tune those processes, as a result, you can really obtain an environmentally pure engine that will be very friendly to the environment. So I wouldn't be supporting our colleagues from Western countries that the CO2 is the reason for the greenhouse effect, unlike the CO. And so the use of the transportation system has the future, because we need to develop a versatile fuel, something that is going to be easy to obtain and to use. If somebody comes to me, a chemist, and would say, we have this molecule that has a very stable chemical structure, it will oxidize very well under certain conditions, and I will tell him that we can create such a process that will allow them that we will have full combustion, so that we would ensure there is the maximum efficiency for this thermal machine. And if I may,
if we just remember a situation 20 years ago, for instance, I used to have this Zhiguli Lada 8, and I used synthetic engine oil in it, and I knew exactly that that would help me to extend the life of this vehicle. If we go to a store now, we will not be able to purchase mineral oil, engine oil. It will be half synthetic in the best case, you know. So if we are talking about the future of transportation vehicles, they will definitely use a combination-based fuel. It may be fuel synthesized from coal, oil, or vegetable oils, for instance. And I believe that this is the future, and we have to support these ideas into the future. Thank you very much. And a question to you. What kind of a personal car or vehicle would you like to have in, say, 10 years? 10 years from now? Teleportation. Well, talking about me, you know, I'm a villager. I live in a village, so I can't be part of car sharing. So I need a private car. It would be great to have a helicopter with a piston engine. But in reality, I think it must be an individual, personal, vibrant car that should be designed here in our country. And I think there will be a presentation here at 12:30 devoted to exactly this topic in this room. Questions from the audience, please. Well, I actually have two questions. My name is Dmitry. I'm from Moscow. And first question to Mr. Gapinovich. You were referring in your presentation to a project when I use the third ring and I see this Lastochka train moving. My impression is that there are few people on board that train. So have your forecasts coincided with the actual numbers? And to Mr. Gordon, does Russia need a new long-range airplane? Vladimir Alexandrovich, the floor is yours. As far as this MCK project, our forecast did not coincide with the real numbers. Together with the government of Moscow, we did not expect. Well, I actually had a talk with a representative of the government yesterday, you know, and we are going to overcome 500,000 people. We didn't expect such numbers, so we didn't probably sufficiently studied the passenger flows, but we are trying to reduce the intervals. So there was a mistake, and we are going to correct this mistake. It happens. I would like to maybe reformulate the question. In fact, it's not only Russia that needs such a plane. It would be good for the world to have it, you know. And what we are doing now, creating a large fuselage, long-range airplane, passenger airplane. Russia is a huge country. And since the project is a joint project with China, I think it's the right way to go. Why don't we kind of introduce something new into the range of Boeing and Airbus, something of our own? My name is Maria. I'm from the Moscow region, and I'm a student of Russian Transportation University. You mentioned passenger carriages, but you didn't. Well, you didn't mention. You didn't speak too much about the cargo cars. What are the prospects of developing the cargo carriages in the future? In fact, there are about 1 million carriages. Cargo cars, freight cars. And we are now involved in a very serious research effort in developing the cargo transportation. And We have had already experiments with 14,000 tons trains, and we are also Uralvagon Zavod, for instance, is testing higher axle loads than container carrying trains. For instance, we're testing the Murmansk line, testing it at a speed of 160 kilometers per hour. I mentioned a number of roads, though, and we need to invest a number of trillions of rubles in order to develop those projects that I mentioned in my presentation. It is important also to provide for the transportation of fish products from our seaports in Russia. Anton Zhilev from Izhevsk. My question is about the technology of people speak about additive technologies for the production of better quality metals, but do you use these new technologies in your industries? May I say a few words about additive technologies? Probably the majority of you already have experience of printing something onto 3D printers. And you probably noticed that there are a few problems associated with that. It's the density of the material and then its efficiency, because you have to wait for hours until it's finished printing. Unfortunately, we do not have Mr. Rakhmanov with us. He would say here that they have for half a year already been printing a propeller. So it took them a half year. But if we take, for instance, a car body, maybe the whole body may be printed in 1 hour. It's probably not needed. In fact, we are talking about printing something very complicated. It's like the end of a joint. I think the process will soon be taking just a few minutes. So we are used to the approaches where the flat material is used, using presses. I think this will become past very soon. Some things definitely will be easier to produce using traditional technologies. But the 3D printers will definitely be used more and more extensively. When we produce certain things using traditional technologies, we have a mass of material, and there are a number of zones where the tensions are not really very high, so we have to just suspend material. If we speak about 3D printing, people say a lot about bioengineering. But the material should stay only where it is really needed. Then the border conditions will be preserved. However, the inside materials will look quite differently. So please do not ignore 3D printing, neither in your projects or in your tries to produce certain models. And the industrial technology will definitely follow suit. One more thing, the additive technology aspect, one of the most important additive technology aspects is the question of outcome. We are in metalworking, have been in metalworking for a long time, and we know how additive technologies influence the quality of the material. Well, a combination of technologies is used, and in order to achieve the same level of reliability, it is hard because some tensions are actually removed. You remove part of the material, and then if you remove it, then you actually may undermine reliability of this or that part. So in aviation, for instance, 3D technologies are falling behind other technologies. Airbus, for instance, does use the 3D printing for certain elements of wings. There's definitely a movement forward in this area, but we have to think about reliability first. There are certain computerized complexes that actually allow to preserve certain characteristics. I just wanted to ask you about the regulatory basis. I read that Airbus and Boeing are already applying this technology, but in Russia, we do not have standards and we do not have regulations. That is to say that if there's tension, why is it not being developed? Well, we are actually actively doing that, and in order to coordinate the technology, you have to first make it stable, then to produce certain parts, and then start using them. It's a long-lasting process. For instance, we're printing now certain parts, but we'll see how reliable they are. Airbus and Boeing and GE are already following that path. They have their internal regulations, and in fact, they have been already following this path for a long time, so they are already demonstrating certain results. Well, thank you very much. That's the last question, please, and we are pressed for time here. Good morning. My name is Mikhail Vladislav. I'm an associate professor of the Moscow Institute of... You said that there are certain borderlines to unmanned aerial vehicles that can carry passengers. Timeline, in fact, was it 2050? Did you say 2050? In fact, it's already possible to carry passengers on board unmanned aerial. In Dubai, for instance, there's already a test going on, and aerial vehicles are used as taxi cabs. So, do you think... Well, when I was referring to 2050, I actually meant long-range passenger airplanes. But as far as carrying passengers by unmanned vehicles, it's, even today we can do that. However, you know how this unmanned aerial vehicle system will be coordinated with the activity of the so-called traditional system. It's not decided yet. It's not resolved yet. It's still an issue because there's no legislation. Just if we take an unmanned aerial vehicle and we allow it to fly, we want this area where it's going to fly be closed for other means of transportation. But this is exactly how the legislative requirements are at the moment, because there are certain dangerous implications here. And then there's another thing that should be thought of. It's a number of jobs that will be lost because of the introduction of these unmanned vehicles. Thank you very much. Thank you very much for your brilliant presentations. Thank you for your great questions. We would like to invite you to the presentation of the Crimea. We will... thank you very much.